Hello again. So now we're going to look at the probability of dependent events. So this is typically when things are done one after another. We're going to be able to tweak it a little bit when things are done at the exact same time. But um, the probability of both A and B occurring when B is dependent, which does not mean it like relies, well, yeah, okay, when it's affected in some way. Dependent on A, that's supposed to be on A. So the probability of A and B happening is the probability of A, right? It's the chance of A happening times the probability of B after or given that A has happened. So you pick one of them to happen first. Probability of this one happening times the probability of this one happening after that one has happened. All right? Let me show you how some of that works. We're going to actually make this really fairly simple. Got a bunch of examples, just kind of jump into this. Remember, if I move too fast, pause, rewind, play slower, all that other good stuff. So if you're drawing cards from a deck without replacement, and that's going to, drawing off the screen, without, my handwriting's horrible, ignore that, that's without replacement, and that's usually going to be your big word, big key phrase for saying, oh, these are dependent. If it's with replacement, that means we're going to start over each time. Those would be independent, and that's like, what, Monday? You just find the probability of each independently of each other and multiply them together. From a deck. Oh, without replacement. All right, we need to find the probability of drawing a king, comma means and then another king. All right. So first, we're going to find the probability of getting that first king. All right. You have the whole deck of cards. Hopefully you have that. You haven't lost your little sheet of a deck of cards or your file from a deck of cards from last week. All right. The probability of getting a king the first time, well, there's 52 cards, and 4 of them are kings. And I don't reduce until I'm ready to actually do math because this makes this a whole lot easier. Times. Now, you have that king. Okay? Hold it, keep it, don't forget that it's there. Now, when I go to get this king, A, there's only 51 cards left, right? Because that's a king right there. King 1, king 2. Now, if that's a king, I only have 3 kings left. Now I can feel free to reduce, right? 4 over 52 is just 1 over 13. 3 over 51 reduces to 1 over 17, and I'm left with whatever 17 times 13 is. That's no fun. Gotta turn my calculator on. I used to know this stuff off the top of my head, but welcome to the coronavirus. My math skills have deteriorated. 1 over 221. All right? And that's the probability of getting a king and then a king. All right, same situation, but now the question is, what's the probability of getting an ace and then a king? All right, so let's do the first one first. That's probability of getting an ace. There's 4 aces out of the 52 cards, because when I go to draw the first card, the entire deck is there. Now, I have an ace. What's the probability of getting a king? Well, now there's 51 cards, but there's still 4 kings, because that's an ace. All right, so now it's 4 over 51. Now I feel okay to reduce. That's 1 over 13. That does not reduce. That's 4 over 51. Right? So now I have to pause, so that becomes 4 over 663. Good stuff. All right, let's do more. You're going to have like uglier word problems to deal with at times. So, a hospital has 15 nurses. That's 10 women and 5 men. Almost off the screen. On a shift. At once. All right? If a doctor needs to find 2 nurses to help him, her, I made this problem up, doctor's just going to grab, he has like emergency surgery or something going on, he's just grabbing the first 2 nurses he sees, or she is getting ready to have a surgery, and she grabs the first 2 nurses she sees. I'm not doing both of them just because I'm trying to be simple, all right? What is the probability that both nurses are female? All right? This, again, if you like slowly go through it, this becomes simple. All right? Probability of female and then another female. Right? Instead of trying to think about, oh, he's grabbing the 2 things at once, it's easier just to think, okay, technically he's getting one and then the next one. Right? If you smart aleck technicality people, if I get down to like the microseconds, he's going to see one before the other. All right? The first time he goes to get a nurse, right, it's 10 out of 15 because there's 10 female nurses there and there's 15 total nurses. Now, when he goes to get the second nurse, there's only 14 nurses left because he's already grabbed one. Or she's already grabbed one. All right? And there's only 9 female nurses because in order to have both of them be female, the first one had to be successful. Right? In order to win twice, you have to win once first. So that's only 9. Now I get to reduce. 10 over 15 is 2/3. 9 over 14 does not reduce. By the way, you can just multiply across, put in your calculator, fraction, enter. We'll get you there. That goes in there 3 times and once. That goes in there once and 7. However, since I don't like grabbing my calculator, that's 3 over 7. That's the probability of getting 2 female nurses. All right, I'm hoping that makes a little bit of sense. When needed, draw it out. Do one step at a time. Get the first one, cross them out. For instance, some of my people that didn't like doing this before, you would draw 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. There's my nurses. All right? 10 female, 5 men. So the first time I get a female nurse, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 11, 12, 13, 14, 15. 10 out of 15. Right? And then I cross one out because I've done that. Now there's only 14 total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 1, 2, 3, 4, 5, 6, 7, 8, 9 females. Right? And then you stop because I only need 2 people. And then I would grab my calculator, multiply across. 90 over 210. I hope that's right. Reduce, that becomes 9 over 21. which becomes 3 over 7. Yay! All right. That's my non-calculator version. All right. I've taken up tons of time now. Have fun. That should make sense. If it doesn't, get in touch with me. I will help you work through it.